Welcome to Developer Server's YouTube channel. On today's episode, we're going to be building an MCP server using FastMCP. And what is FastMCP? FastMCP is the fast Pythonic way to build MCP servers and clients. It allows us to easily define tools and to create an MCP server ready to be consumed by Cloud Desktop, Cursor, or any other MCP consumer. So what is a FastMCP server? A FastMCP server is a server that allows AI models to interact with external tools and data sources through a standardized protocol. You can see for the project structure that we are going to go through, we have a simple client example and a simple server example, and we also have a composition, meaning a set of sequence of tools that can be called by the AI. We have the example for a client and a server for that composition, the dependencies, and of course this README file. I will leave the link to the GitHub repository in the description of the video, and you can check it out by yourself. So let's take a look at the requirements. We only need FastMCP, the package that we just saw to create the MCP server. Now let's take a look at the server example. As you can see, we're doing the import FastMCP from FastMCP package. We are creating a new instance of a server. We are creating a tool by using the decorator mcp.tool. We define a tool, in this case it's just a simple Python function. Define a tool called greet, receives a name and returns that as a string. Name is also a string, and returns hello in that string that is passed. And we define to run the server with the if main as standard in MCP run that will run the server when needed. For the client example, we're importing async because we will be using an asynchronous call, and we're importing the client from the FastMCP package. We'll be creating a new client, and you see that we create the client by specifying the path of the servers or the file name of the server, because this will automatically start the server when needed. Then we define our function to test call the tool, and we define an async function that we'll call, in this case, call tool, receives the name as the actual tool receives. Then we're defining an async quit and the client, and this allows us to structure our code inside that block. And we will be awaiting the result of the client call tool, and call tool will be calling the tool greet as we define in the server, and we're passing in as parameters the name, which is the name that we also receive in this function. Then we can run the class asynchronous with async.run, and we call the tool, which is the function that we defined here before, and we pass the name for. And if I run this code, execute the tool, we have the result of the call tool. We pass in the different context, we pass in the text hello Fort, and the structural content is the result that we come back, in this case the hello Fort, and also the date is also the result. And as you can see, this is a very simple way to create a FastMCP server, and also a simple way to create a client so that we can test the tools without having to worry about AI calling our tool or not calling our tool. Let's see now an example of a more complex tool sequence that AI might infer. Again, we start by defining our server. In this case, we're calling our server pricing tools, and it's in a file called server composition. So we create an instance of our server by using the FastMCP. We define the first tool, which we're going to be doing a product lookup. Again, all tools are defined with mcp.tool. So we define a tool get product, which receives a product ID and returns a dictionary, which is the product information. Define a second tool that is a tool called apply discount, which receives a price and a discount percentage, and the output of that is going to be a float, which is the applied discount. And we have another tool which will be able to format the message, which reserves the name and the final price, of the name of the product and the final price of the product, and returns a formatted string. Again, we run the server, or we have the possibility of running the server with mcp.run. And if we take a look at the client composition, so the client for this server composition, again, is async, JSON, and importing the client. So we start a new client with client equals client with the name of the server file, server composition. Then we define again our async function to call the different tools, and we do our async with the client that we just created. And then we're going to go through the different tools. First, we're going to get the product. So we're going to be doing the client call tool, the get product tool, and we're passing the product ID, in this case 42. We receive back the product, which is a tool invocation data, as we saw before. So the actual data that is returned from the function, it is inside data. So that's why we assign the product back to product data, or the product data assigned back to product. We then apply the discount. That means we're going to call the tool apply discount. We pass in the price that we just returned before in the previous function, and the percentage that we want to apply the discount. Again, the result of that function invocation tool. It's inside data, so discounted is equal to the discount data. And then we format the message by calling the tool format message. We pass in the name, which is the product name, and the final price, which is the discounted price we obtained from the previous tool. And again, we get the final message that is the formatted text from the message data, and we print that message. And again, we run the client asynchronous with async.run, and we call the tools, which is the function that we just saw before. So let's run the code. So we run our client composition file. It will start up the server, and it will invoke the different tools, and it returns the output as we saw. The product headphones is available for 102, so that's the invocation of all the different tools, with the format message being the last tool invocated that gives the output formatted. And that is it. That's how you can easily create an MCP server with different tools. We're using FastMCP. As you saw, for instance, the server composition, you can easily define a different set of tools. You can test them without having the AI mess up calling or not calling the tool. So you can make sure that all your tools work. And then when you put the LLM as part of the MCP invocation, then you can be sure that your tools will work. Like this video if you like this content, subscribe for more content about Python, Django, and AI, and until next time, happy coding!